Hey, what's up? It's Jake from Nimbus DevOps, and today we're going to talk about private methods and name mingling. So, if you have any kind of programming background, you know that programming languages like Java or C allow you to assign a privacy status to attributes, whether that's the data or the actual method. Each language does this differently, but basically the public attributes are accessible from any point in the code, and the private ones are only in the scope in which they're defined. So in Python, that doesn't exist. Everything is public. So we rely on conventions um, for privacy, like name mingling. So the convention's kind of like this. If an attribute's name has no leading underscores, it's considered public. So you can access it, modify it freely, whatever. When the name has one leading underscore, the attribute is considered private, which means it's probably meant to be used internally and you should not modify it or call it from outside. A common use case for this would be like helper methods that are supposed to be used by public ones, or internal data like scaling factors, or any other data you'd want to put some kind of constant, like a variable that can't change. Um, but Python actually doesn't have those either. But the characteristic is kind of intimidating if you don't use it a lot, um, because of like privacy or constraints or whatever. But it's really not that bad. So don't sweat it. We'll go over an example here. So let's say there's a call for privacy that makes sense. Like we want to find a reason that this makes sense. Um, because without it, you could get like a bug in your code or something like that. And so we'll go back to using classes to show you. So I'm going to make a class A and define, initialize, and we'll say self and factor. Okay. And self dot factor is actually, we're going to do self dot underscore factor equals factor. Okay. And then I'm going to define op1 as self, and I'm just going to print op1 with factor, and then dot format self dot underscore factor. Okay. Then I'm going to make a class B that takes argument A actually, and we'll say, hey, define op2 that takes self and factor, and we'll say self dot underscore factor equals factor, the same thing, right? Um, and then we'll just print that out. So print op2 with factor dot format self dot underscore factor. That looks good. Okay, cool. So we have two classes. So now I'm going to make an object, and I'm going to say B for 100, and then get the object.op1, and then I'm going to get object.op2 and pass 42, and then oops, and then I'm going to get the object.op1 again. So in this code, we have an attribute called underscore factor right here, right? And so let's pretend it's so important that it isn't modified at runtime after the instance is created, because op1 depends on the function correctly. So we've named it with a leading underscore. But the issue is that when you call object obj.op242 on line 15, we modify it, and it's reflected in the subsequent call to op1. So you'll see it correct here, and then we're going to modify it, and then you'll see that this object actually changes. So let me save this, and let's go to my Python scripts folder, and let's just run this and see what it looks like. So Python private. So 100 and then 42, and then all of a sudden it's changed and OP1 is now 42. So we can fix this because this is an undesired behavior, and we can add another leading underscore. So if I just add this underscore, right, and then I'd have to change it here, and I'd have to change it here, and I'd have to change it here. So this isn't related, but I will let you know there. If you use a search functionality in VS Code, you can do a search for like underscore underscore factor, and it will find those, and I can just replace that with like underscore factor, and um, and I can just replace all of them if I wanted to. So I have this, and then it says replace all, Control Alt Enter. So if I hit Control Alt Enter, replace, they've all now been changed. And if I wanted to change it to double underscores, I just look for underscore factor, and then I want to replace it to double underscore factor, like this. And I just want to do, I don't want to do all of them. I just want to do private, this guy. Boop. So I can replace all here, and I get double underscore factors. So I just figured I'd show you that really quick. The find and replace is super handy. So now let's run it and see what happens. 100, and then this one off for OP2, it does change it to 42, but then when I call OP1 again, it correctly returns 100. Okay. Um, so name mangling means that any attribute name that has at least two leading underscores and at most one trailing underscore has a underscore my underscore attribute and is replaced with a name that includes an underscore and the class name before the actual name, such as like here I'll type it out so I'm not just talking about it. So you get a underscore my underscore attribute, and so what I'm saying is that um, it's replaced with a name that includes an underscore and the class name. So you'd have underscore class name, whatever that is, underscore my underscore attribute. So it'd be like that. So that means when you inherit from a class, the mangling mechanism gives you private attribute to your private attribute to different names in the base and child class so that name collision is avoided. Every class and instance object stores references to their attribute in a special attribute called dictionary, so underscore underscore dict, like that. And you can inspect that with obj dot underscore underscore dictionary underscore underscore. And you can let me move that up. You can inspect that like this to see the name mangling in action. So if I wanted to, I could delete this, and I can just call this by saying, hey, print out, so we can see it, this dot keys. We want to see the key values. Okay. And if I print it at the end, you'll see A factor, B factor. If I printed it right before here, and again before here, and again before here, you can see, okay, dictionary keys A factor. And then the first one, OP1, A factor. OP42, A factor, B factor. And then the last one is A factor, B factor. So it has now two attributes. The A factor mangled with the A class and the B factor mangled with the B class. So this is the mechanism that ensures when you do object dot underscore factor equals 42, that underscore underscore factor is A, or in A, hasn't changed because you're actually touching the underscore B underscore underscore factor, which leaves underscore A underscore underscore factor safe and sound. So if you're designing a library with classes that are meant to be used and extended by other developers, you need to keep this in mind to avoid anything unintentional like overriding your attributes. Bugs like these are pretty subtle and they're actually really hard to spot, especially when you have to use something like printing out the object dictionary keys just to even find where the problem is. So the last couple of videos that we've done has been a lot about these little tiny details, and the devil is in the details. So when you're coding and you have a bug, sometimes it's good to take a look at the different methods and print out the output to make sure that your code is doing what you think it's supposed to be doing. So anyways, that is all for private methods and name mangling. If you have any questions, let me know. And if not, then happy coding.